Hi there. So today we're going to be talking about graphing methods for describing data. So the first part of data that I'm going to be talking about today is categorical data. Now, categorical data, it is placing your data into qualitative groups. Now, qualitative in itself is more describing the numerical. Now, what I mean by that is you can have numerical data where it's numbers, but categorical focuses more on, like I said, qualitative, aka the qualities of something. Now, for an example, we can describe cars, because everyone likes cars, right? So, with cars, we can use a bar chart to describe it, in which we do colors of cars. Now, let's say we do, in a neighborhood, there's 1, 3, 5. That'll be our scale. Let's say that there is 2 blue cars. There is 4 white cars and 5 black cars. This would be an example of categorical data because you're describing by quality. Now, as I've shown you right here, you can describe categorical data with bar charts, in which these bars are separated. You can use a comparative bar chart, in which you can, let's say we have our black, our white, and our blue. Again, I won't label them, but you'll understand what I'm saying. And then we'll do that again here, here, and here. Now, instead of just describing one neighborhood here, you're going to be describing possibly 2 neighborhoods, neighborhood 1 and neighborhood 2. You would just have to label these, so then whoever's reading your graph would understand this is blue, this is white, and that's black. And again, you're always going to need your scale, and you're always going to label your axes, number and neighborhood. But now with comparative, an extra step of labeling is required because you have to label each individual by color coding, writing it on there, or various forms. You'll figure it out. Now, another way is a pie chart. Now, it is not like 3.1415, that infinite number, and I'm sure that's not the one you thought of first, but it's not the pumpkin pie that you eat at Thanksgiving. A pie chart is a big circle, and it's divided into specific sections. Now, if you have seen business classes or attended business meetings, for example, you will have seen that they use pie charts quite frequently because they can describe. Now, let's say we go, for an example, let's go on a more serious note, and we go with government spending. Each piece will be a certain percentage, and all of the percentages will equal 100%. So let's say that this is going to be healthcare. And I don't know the exact numbers, but let's say we spend 15% of our entire budget on healthcare. Now, military, let's say that we spend 50% of our money on the military. That's a bit close, I think. But see, this is not going to be an accurate to scale pie chart because if that was 50%, you would have less categories here because, 1 second, 50% would take up half of the bar chart because 50% is 1/2 of 100. Now, pie charts can vary from the sort that I'm showing you right now, but we can also have pie charts where specifically, one second, where you can, it's not writing. One second. Oh, there we go. It was on eraser. So we can have various groups of pie charts, but then we have a section of it separated. This is a very poor drawing, but this is supposed to be the chunk represented right here that's taken out. So about a quarter, so 25%. Now this is basically applies as the same method of showing data as a normal pie chart, except this adds emphasis. Now, to move on to show more forms of data. One second, let me just. I'll just take 1 second. Actually, I'll just edit back in when I get this figured out. Alright, I'm back. That totally didn't take 15 minutes of just trying to figure out how this app works, because it's a newer version. Anyways, so now we're going to talk about stem and leaf plots. Now, stem and leaf plots is a comparative form of data showing. Where it splits the data sets. Now, let's say that we go and we pull up some data. And let's say it's the number of free throws Team A is able to accomplish and Team B is able to accomplish. So let's say we have 1, 3, 5, 7, 7, 10, 10, 12. With this one we have 2, 2, 5, 7, 10, 11, 13. Now, with this data, it is sort of hard to compare it just by looking at it, so that's why we have the stem and leaf plot. So what you're going to do is you're going to first create your stem. So this is, we can label as stem, and let's say that this leaf is going to be for Team A. This leaf will be Team B. B. So what we do is that we're just going, the stem is going to be represented by, how do you phrase this? It's represented by how many numbers are going to be there in this data set. So if you have 1, 2, 3, 2, 5, 5, 7, 7, 7, all of these numbers have only 1 because it's not 10, because these ones have 2, if you see. So what you're going to do for your stem is you're going to label your stem 0, and then you just add for Team A 1, 3, 5, 7, 7. Now I made this very nicely set up so it's in order, and it's not always going to be in order for you, but I recommend that you put it in order yourself, so then when you have to find stuff such as the mean, median, mode, it's going to be a lot easier for you. Now this is a relatively simple data set, so because there's only 2 in question, so our stem for the next one's going to be 1, because these all begin with in the tens. So we're going to do 0, 0, 2. Now on the other side, we're going to do the same thing but for B. So we're going to have 2, 2, 5, 7, and then 0, 1, 3. Now we can compare this data a little bit better. This is a very small data set to compare, so when you get larger data sets, you're going to be able to see if there's a definite trend in the graph, such as if it is left skewed, right skewed, or it's a normal distribution. The next one I'm going to talk about with this. One more thing to mention. Let's say your data sets are a little bit funky and they're not just perfect integers. Let's say you have 10.78976. But you don't want to have to put that out on a graph, like let's say 1 and then 0.78976. You don't want to do that. So a popular thing to do in the AP Stats community is to truncate. That is simply that you are just going to cut it off at some point, and you're going to exclude these three numbers. So instead of having to do all of that, you simply only have to do 2. Now, truncating is a bit harder to explain on the AP exam, so often what they prefer you to do, let's write the number again. Let's just say you round instead. That's a more popular opinion. So what you do is you just round that, and since it's higher than it's 5 or higher, it's going to round up. So you're going to have 10.79, and that's a lot easier. And see, these data sets are going to be very similar, so you are going to deal with some variance in your data because of this, but it's not going to be very noticeable unless you're truncating extremely or you're rounding extremely. Okay? Now, next about the stem and leaf plot is that you can also divide it into highs and lows. Because, like I said, let's say you have 40 data points, and you don't want to have to graph all of those. What you can do is that you can do this, and all you're going to have to do is do your stem, and you can have 1 high, 1 low. Actually, it's actually preferred to be done in the opposite way, where you do 1 low and then 1 high, because it keeps it in order. Then 2 low, 2 high, 0 low, 0 high. You get the idea. And it basically splits your data if you have large amounts of tens numbers into low numbers and high numbers, better displaying your data spread. Okay, I'm going to cut to when I reset this again because I made a mistake. Okie dokie, folks. Next part of the lecture I'm going to talk about is we're going to go back to bar charts. And there's another part of bar charts and bar graphs that is associated, and it's called segmented. Bar charts. And this varies from your typical bar chart and comparative bar chart because instead of having the data, oh my goodness, that is very skewed. That doesn't look very pretty. There we go. So instead of it being separate data sets like that and that to compare two different things or comparing the same things but in different situations like neighborhoods, like such and like such. Instead, we're going to, with the segmented bar chart, let's just draw an arrow. It says, no, no, yeah. So basically, you're going to draw your bar, and then you're going to stack the next data set on top of it. And so this is often used in situations such as responses like, how likely are you to buy a JCPenney gift card? We've all seen these surveys where they ask us our likelihood, and we have very likely, somewhat likely, likely, somewhat unlikely, unlikely, and not likely at all. So basically, we would stack the data values of likely, somewhat likely, very likely on top, and the bottom one is always going to be the largest, and it's going to descend from there upwards. So, next one to talk about is going to be the histogram. Now, your histogram can be found on your graphing calculator very simply. You just have to type in some data values. I use an Nspire, so with that I would have to use spreadsheets, and you would just type in all of your data values into a spreadsheet-like format. They all look the same, whether you use an Nspire, TI-84, 83, or the various brands. And basically, your histogram, one second. So your histogram is going to look like a bar chart, but all of the data is going to be continuously connected. So, but how it's different from a bar chart is often these are going to be separate variables in a bar chart, but when a histogram, it's going to be the same thing, whether it be deaths over time, or likelihood to buy a JCPenney's gift card, or likelihood to go to a poorhouse because your AP Stats teacher didn't teach you enough. So stem and leaf plots are a wonderful way to map data, but it's not always the best way to summarize data. Let's say that you're given a data set of 1,000 different data points. You can't be expected to get a stem and leaf plot and do each of these individual little stems and have thousands of leaves. That's not going to work. So histograms are actually more effective for, let me write this down, more effective for large data sets. See, it's much easier to type all of these numbers in on your calculator and have it generate a histogram for you than it is to do a stem and leaf plot. But what these both do is they show the distribution of the data. So like I stated previously, you could look at it and see if it is a normal distribution, skewed left, or skewed right. Now, that's about all I'm going to go into a histogram, because it's a fairly simple concept, because let's see, because with discrete numerical data is more applicable to histograms. I'll go over that in a second. Because with histograms, like I said previously, you're going to be not only able to graph large amounts of data sets, but it's overall going to be easier with experimental design questions, because experimental designs often have a lot of discrete numbers where you're expected to have large amounts of data, and it just makes it a hell of a lot easier for when you're on the AP exam. Okay, so next thing I'm going to talk about, it's going to be dot plots. Now dot plots, let's see, there's various ways to show dot plots, but I'm just gonna, and there we go with my crooked graph again, but that's gonna be okay. Sometimes it's okay to be crooked. So let's go to my favorite scenario, and it's talking about ice cream. Now, 2, 3, 4, 5, 6. Now let's say you were tasked to go out and find out how many scoops of ice cream your high school eats. Now, we're going to label our axes, as always. Now, let's say we divided this into scoop numbers. 1 scoop, 2 scoop, 3 scoop, 4 scoop, 5 scoop, 6 scoop. And with a dot plot, you're going to go out and you're going to collect your data of how many people eat amount of scoops, and then you're going to graph that by, let's say, I'm just going to, just trust me on this, that this goes up by ones. I'm not going to label this. But let's say 2 people out of the sample that you took eats 1 scoop. Let's say 4 eats 2 scoops. 3, let's say that's our highest at 6. 4 goes down to 4 again. This is just a very poor interpretation, but I hope you get what I'm trying to show you. But basically, that's how many scoops people eat and the frequency of people eating that scoop. Notice how nobody ate 6 scoops. This can be shown as selection bias because you didn't get enough people that possibly eat 6 scoops, but often with simple random samples, it's just the luck of the draw, and you're never going to have a perfect representation. Now, this also, like all the others that I've shown you, like stem and leaf and histograms, it shows you the spread of the data. And now with this, if you look at it, it is a fairly normal distribution of your data. Making things a lot easier on you when you have to do this. Now, actually, while we're here, I'm going to go into the various forms of skew. Now with skew, let's say, I'm just going to draw this out real quick again. 1, 2, 3, 4, 5. 2. Now, let's say scoops, and this is going to be frequency. If most of your data, I'm just going to do a bunch of dots like this. This isn't how your dot plot should look, by the way, because this data is discrete, meaning that it is one number or another. It has to be an integer. It's either 1 or 2. It can't be in this middle area. But let's just say we're doing this and your data ends up looking like this. This would mean that your data is actually right skewed, because your median out of all this data, let's say it's going to be around here, because people typically eat 3.5 scoops of ice cream. But your mean is going to actually be more in this area, because this data is skewed because you have a large amount of people that are outliers. This is going to be typically seen in situations such as money, price of housing, etc. Because you're always going to have that one random person, not often your AP Stats teacher, but this one random person that makes so much more money than the rest, or there's going to be that one house for some reason costs $3 million more than everyone else's, and it's going to cause your data to be off. At that point, we would get rid of this outlying data to make it more of a normal spread, but in this case, it serves a lesson as to what right skewed is. Now, left skewed, I'm just going to do a quick and crude interpretation of what left skewed is going to be. Your left skewed data is often going to look like this. Because it's going to be the reverse of this situation, where you're going to have people making, like, let's use money for example, they're going to be making a lot less than the average person. Let's say, I don't know, an AP Stats teacher. Well, the median is going to be largely up here. Now, that distribution can be demonstrated through dot plots, histograms, or stem and leaf plots. Now let's go ahead and move on to the next item. We're going to do box plots. Now, with box plots, you're going to typically have a number line. Well, not typically, always, really. You're going to have a number line with, let's say, one. Let's just draw all the points out real quick. I just want to clarify that all of my drawings are going to not always be drawn to scale, and it's just more of a crude representation to get a message across. Your box plot is going to demonstrate several key elements. It's going to tell you what the lowest value of the data set is. It's going to tell you what the first quartile is. Your median, often called the second quartile. Your third quartile. And lastly, your highest value. how we're going to demonstrate this in here, let's say we're going to do scoops of ice cream once more, because who doesn't love ice cream? We're going to, let's say our lowest value is going to be 1, highest value is going to be 8, then your data, let's just say like I said, very crude drawings. So basically, how you're going to identify the elements of this is going to be your lowest value. This is going to be your first quartile. This is going to be your median or second quartile, your third quartile, and your highest value. So we can actually gather a lot of data from this. We can gather, like I said, the lowest and highest value of this, so then you know the spread of your data. You're going to know how much variability you're going to have here. You're going to know the first quartile, second quartile, and the third quartile, meaning you're going to be able to find an interquartile range, IQR. And with your interquartile range, you're going to be able to find out what values are outliers. Now, let's go ahead and apply that to this scenario. We're going to have a median of 6. First quartile is going to be 4, and your third quartile is going to be 7. Now, what you're going to want to do to find outliers is you're going to do IQR times 1.5, and then you're going to add that to the third quartile, and the same thing will apply to the first quartile, but you're going to subtract it from quartile 1. Or rather, it's going to be quartile 1 subtracting this. So let me go ahead and move that. Now, how you find your interquartile range is simply by subtracting your first and third quartile. So 7 minus 4 equals 3. Your interquartile range is going to be 3. Now, IQR times 1.5 is going to be equal to 4.5 plus your third quartile, 7. How we're going to do this is your first quartile is going to be 4. It's going to be minus 4.5. And that's going to yield 11.5 and negative 0.5. So any data values higher than 11.5 and lower than negative 0.5 in this data set would be considered outliers. But when you look at the spread of our data being 1 to 8, you're not going to have any outliers in this data, which is kind of great. But if there's too much data, then it's not the greatest thing, because you don't want to have to deal with all of that. And so with this, the next concept I'm going to go over is frequency. Kind of a weird segue, but a segue nonetheless. Frequency is the number of times you have received a response. And so the frequency of your data can be very varied. So if we can bring back our dot plot, actually, we can talk about scoops of ice cream again. And with frequency, like I said, oh no, let's see. Here we go. Frequency. Like I said, it's the number of times given a response. And now this is not the math given like A given B. We're going to talk about that in the probability unit. Given is just referring to how many times you received a response from someone. So scoops. For example, the frequency of 3 scoops occurring is 1, 2, 3, 4, 5. So we can count that So the frequency of that is going to be 5. So what we can do now with that is we can find the relative frequency. With the relative frequency, it is going to be the percentage of that response occurring, so in that case that, and that's going to be found by the frequency of whatever you're finding divided by the total. So if we count up all of our data here, it's points rather, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if we just quickly do 5 divided by 17, let's see if you can beat me to getting my answer. Probably will, I'm taking forever with this. You're going to get, your percentage is going to be equals 0.294111765. Now, in the case of AP Stats, you'll often see that numbers typically go to 3 or 4 decimal places. So this is actually just 0.2941. Now, this isn't the actual percentage itself. You would need to multiply that by 100 to get 29.41%. And so I've already talked about the difference between categorical and numeric data, but I'm just going to hit upon that one more time to clear up any feelings that anyone might have of confusion. So we're going to have categorical data and numerical. Categorical is going to be qualitative data, where you're describing something. Think when you look at this, quality. So, and then also about this, you're going, with qualitative data, you're going to have that be your bar charts. And under bar charts, you're going to have this form of bar chart. You're also going to have your comparative bar chart. One second. And then you're also going to have your pie charts. Where the type also varies with the one described right here, where it's just one whole pie. Pie sounds good right now. Let me draw that a bit better. And then you can have pie charts where they provide emphasis, where, like I described before, where the data chunk you're talking about specifically is separated from it as a whole purely for emphasis. Now, with numerical data, it's going to be your quantitative data. Now with that, you're going to have numbers, not categories. Now with this, you're going to have dot plots, stem plots, if you need a refresher on what all of these are, just go back further in the video. And you're also going to have your histograms. Now, with all of these, some of these have various benefits and disadvantages to them. With dot plots, what's great about dot plots is that it shows gaps, outliers, and clusters in your data. Clusters being, if there is, for some reason, a large amount of data gathered around a couple of points, like a couple of values like 2 and 3, that's a cluster of data there. Outliers, I've already talked about that and how you find outliers, and gaps, where basically, a quick example would be if you just have some data and you just have it going up like this, and then it goes down, then it stops for a second. Actually, we can use this to demonstrate everything. Your gaps, it's going to be this one little awkward space that no one's inhabiting. Your outliers are going to be right here, and these both are clusters. Stem plots, well, actually with dot plots, you don't, disadvantages of dot plots is that it's only good for small data sets. Because if you have too many, it's not very good because it sort of loses the distribution scale that it's showing you. Now, with stem plots show, again, gaps, outliers, and clusters. But this is also something for mainly small data sets. All of these, though, what they have in common is they show distribution. Now with histograms, well, here, let me draw a quick little illustration of these. I'll go back and do that for categorical also. You can have your stem and your leaf, 0, 1, 2, and then 1, 1, 3, 4, 7, 8. Now, with histograms, these are good for large data sets. But this doesn't always show outliers and gaps. Sorry, that was my phone, if you heard that. And that's pretty much all I have to go over with you on this, because I've demonstrated you all those different stuff. Oh, and ogive. I'm going to talk about ogives. Oh wait, first I'm getting ahead of myself. Let me draw the various bar charts. We have bar chart, comparative bar charts. Then we have the one I described earlier, where they're stacked on top of each other. Pie charts, I already gave you an example of. Now, ogive is a very interesting concept. One second. Ogive, here we go. And it's not ogive. Pronounced ogive, kind of like how you jive and dance to your AP Stats band or something, if your AP Stats teacher happens to have a band. So basically, ogives, they display data in a very unique way, because ogives can also be called cumulative. I'm misspelling that. I am so sorry. Cumulative frequency. Frequency, very popular word, I know. But basically what this does is it sort of switches up what you see and how you typically imagine graphs. Because in most normal graphs, you're going to have percentage on this side, and what you're going to be testing on this, your sort of independent variable. But with this, what you're going to have is number of students, for example. And let's have this go up by 135, but times 1,000. And then this is actually going to be percentages. 10, 20, and so on and so forth, all the way up to 100. And in this case, it's going to demonstrate what your data by a certain set. You're going to have, like this, for example. This, or not, you're not going to put an arrow at the end. Oftentimes, you're going to have data points being put on here. And with these data points, you're going to be able to find, like a box plot, the first quartile, second quartile, third quartile, and outliers. And with this, you're going to be able to find at or below. Let me write that out. At or below. So let's say this number of students is talking about how many students take AP Stats and enjoy it. Now, let's say how many students are enjoying, like what percentage of students are at or below a certain point. So this can be 40%, for example, and let's see, that comes out to around 5. So 5 and lower, so at that point you would add these up, and that would be 40% of students enjoy AP Stats at or below. Now you can just have it as at, or just as below, but all of it demonstrates the same purpose, because ultimately with all this data gathered, it's going to come up to 100%, no matter what. Okay? And so, and that's pretty much all I have to teach you on Chapter 3. This is, like I said, not really a sort of teaching lesson, more so just something to jog your memory on this.